Hello YouTube, welcome to Study with Cecily. This is a maths one, as you might be able to tell from my lovely poster there. Yeah, this one is on induction and series. Now, because of the course I'm studying, the induction and series that I'll be covering is all the stuff you need to know for the Further Pure 1 module taken with exam board MEI. However, even if you're not taking that, it could still be useful to you because it does cover stuff that's in a lot of topics, and MEI is one of the more comprehensive exam boards in England. Even if you're not in England, then it might still be useful to you just to help with methods and practice. So, yeah, what I'll be covering will be proof through induction, summation of a finite series, using standard results, and using the method of differences to complete a series. Yeah, that's about it. Enjoy! Okay, as I said before, this video is on induction and series. Okay, the first part of this one is the rules of working for induction. For a proof by induction, there are 4 steps. There's proving, true for n equals 1. This is fairly basic. You're usually given an equation and what the answer is when n equals 1. So for a series where each term is un, you are given what? The value of the equation when n equals 1. To prove that it's true, you simply have to sub it into your second equation and see if it gets the right answer, basically. And that's all you have to do. So for example, if you're given the equation un plus 1 equals 4un minus 3, and you're given u1 equals 2, and you have to prove for the equation un equals 4 to the n minus 1 plus 1. Now, to check that it's true for n equals 1, you simply sub 1 in as n. So this becomes u1 equals 4 to the 1 minus 1 plus 1 equals 0 plus 1, which is 1. So yes, that's true. Ding ding! Step 2 of induction is assuming that it's true for n equals k. So assume true for n equals k, in which case the equation would become uk equals 4 to k minus 1 plus 1. Step 3, based on assumption, you assume true for n equals k plus 1. And for this step, you actually have to prove something. Actual maths. Yay. So for this one, is you're given this equation here, un plus 1 equals 4un minus 3. So just sub the n's in for k's, the k's in for n's. You knew what I meant. So it's uk plus 1 equals 4uk minus 3. Okay. And this is UK. So you already have an equation for UK up here, so you simply sub this equation into here. So you've got UK plus 1 equals 4k minus 1 plus 1 minus 3. And if you multiply this out, so if you know anything about how indices works, obviously 4k minus 1 times 4 is same as 4k minus 1 times 4k to the 1. As you're multiplying them, you add the indices, which in this case is 1 and k minus 1, which results in an overall indices of k, as the bases are the same. And then obviously it's just plus 4 minus 3, which goes to 4k plus 1. And as we started with k plus 1, 4 to the k is equivalent to 4 to the k minus 1. Ta-da! And step 4, conclusion. Woo! All you have to write is, so, if the result is true for n equals k, then it is true for n equals k plus 1. Since it is true for n equals 1, then, sorry, my handwriting is not that good, then it is true for n is greater than or equal to 1, and don't forget the important bit, by induction. And that's it. You're done. Woo. Okay, for this module there's, well, not really this module. For this module there is quite a bit of notation throughout the 5 chapters which are in the Further Pure 1 with MEI module. But for this chapter specifically, there isn't a massive amount of notation. So obviously you have, as it's a series, you have the sum of series. So Sn, which is equal to A1 plus A2 plus A3, all the way up to An. Now, as this is a slightly fancy chapter in a slightly fancy module, it also has some sigma notation, which you can actually find in fairly simple stuff too. That was a terrible sigma. There we go, that's a bit better. Got n to the r equals 1a of r. As this is quite a simple series, you simply put the terms of the series here. The number you start with, the first one, which in this case is 1. The number you go up to, which in this case is n. See, pretty simple. And the sigma is just used to mean sum of. Yeah, that's very basic. Okay, so the next part of this video is method of differences. Okay, this is a fairly simple method. Typically, in a method of differences question, you would be asked to do 2 parts. A show that and a hence or otherwise find. Typically it will simply be a hence find, sometimes it's hence or otherwise. The difference between those two I'll get onto in a moment. Okay. So, for example, the show, you're given r 1 over r minus 1 over r plus 1 equals 1 over r plus 1. Now, to do this is fairly simple. You have to multiply both sides. Well, ignore that bit, that's what you've got to prove at the moment. So you have to make this out of these two. So to start with, multiply both sides by r. Or multiply the denominator and numerator of that equation by r. So you have 1 over r minus r over r plus 1. And then multiply by what was the base of those, r plus 1, so you get the same denominator on both. So you have r plus 1 minus r over r plus 1. Because they will now have the same denominator, you can simply combine the numerators into one longer function over the denominator. And from here you can simplify the top, so it's r minus r plus 1. The r's cancel each other out, because it's positive r and negative r, so you're left with 1 over r plus 1, which is what we wanted, so yay, proved. Woo. And now you have your hence. Now, usually you'll be asked a hence, so in order to do a hence question you have to use the method from an earlier part of the question to solve the new part of the question. With a hence or otherwise, you can either do that or you can use a different method, but usually it's easier to just do hence because you already have part of the solution. So for this example, we have to find 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 all the way up to 1 over 29 times 30. It's 30 times 31. I'm making things up. It is 30 times 31. Yeah. You couldn't see that, I just gave you a thumbs up. Anyway. So to find this is a sum of, so you simply have to write it as a sigma notation as we saw on the previous page. Or that's how I like to do it anyway. So this is the equivalent of sigma notation. So your first, if you take q from this, it's r times r plus 1. This is 1 times 1 and 1 times 1 times 1 plus 1. Or 2 times 2 plus 1. So it does fit into this equation. You'll usually find that pattern with this sort of question. So you can simply use as your r equals 1 as your bottom. You can use this equation for your term, and it goes all the way up to r as 30 over here, so put 30 at the top. Now, we've already shown that this equation over here is equal to these two. So to make it simpler, to break it down so it's simpler to do, we can sub that in. So it is, do your little sigma notation, but instead of writing that, you write in brackets. Brackets are important when you're doing a notation between the two, such as this beautiful little subtraction in the middle of this equation. 1 over r minus 1 over r plus 1. Now, unfortunately, method of differences involves writing, and writing stuff carefully. I'm going to start writing it and then I'll explain in a minute. So, to sub in your first one, your first term is r equals 1, shown down here. So you simply sub that in, so 1 over 1 is 1, that's simple, minus 1 over 1 plus 1, which is 1 over 2. and then you sub in 2, which is 1 over 2, minus 1 over 2 plus 1, which is 1 over 3. And then the next one is r equals 3, which is 1 over 3, minus 1 over 3 plus 1, which is 1 over 4. You may be able to notice a pattern here with this one, got minus 1, minus half and plus half, here, minus third and plus third, and here, you may be able to tell the next equation would be 1 over 4. So it's minus a quarter and plus a quarter. Pretty simple. Just to make this simpler. Put in plus signs. And that cancelling continues down, so nice little ellipsis, till we have the penultimate equation, which is r equals 29, because we go up to r equals 30. You can just go straight to r equals 30 if you want to, but it's good at least at first to go to r equals 1 over 29. In this case it doesn't always have to be 29 because it's not always 30. So in this case it would be 1 over r equals 29, so it's 1 over 29. Assume that's cancelled in the previous one, which is minus 1 over 28 plus 1, minus 1 over 29. Minus 1 over 29 plus 1, which is minus 1 over 30. And the final one is r equals 30, 1 over 30 plus 1 over 30, which again cancels there. Done boxes around everything that cancels. And then minus 1 over 30 plus 1, which is minus 1 over 31. So once you've done all of your cancelling, which is all of this bit and all the bits in between, you're left with 1 and minus 1 over 31. 1 minus 1 over 31, which equals 30 over 31. If you can simplify that more, then it's good to do so, because often, especially if you're doing examiners, or if you're going to use a later equation, it's a lot simpler to cancel it down. Unfortunately, this expression does not cancel any further because it's a very annoying little rational number, 30 over 31. And that's it. That is method of differences. It doesn't get much more complicated than that, because usually you'll have the show first and then the hence fine just follows on rather nicely. So that's that section. It's only one more bit to go! Okay, so the last part of this video is standard formulae. Sorry, my handwriting is going to degrade. It's currently 9 in the evening. I wake up at 5:30. I'm going, okay. So, for really horrible problems, such as n r equals 1, r plus 1, 2r plus 2, it's actually not that horrible, but finding the sum of a problem like that between 1 and n, not that nice, but you can use these things called standard formulae. Now, there are 3 of them. There is one for r, one for r squared, and one for r cubed. They are, you have to use sigma notation for all of them. Sigma notation is important. I am lecturing you, but you are upwards. It is important. Sorry if I looked really creepy then, but it is important. I needed to get my point across. R equals 1. From r equals 1 to r equals n. For simple r, it is 1 over 2 n plus 1. For r squared, it's 1 over 6 n plus 1, 2n plus 1. Careful with this one, when I first started using this, I kept writing n plus 2 and getting the wrong answer. Don't be like me. Be smart. Remember your standard formulae correctly. or just use the formula sheet you'll almost certainly be given, because MEI is one of the hardest exam boards in Britain. It's one of the more complicated ones, and it's more specialised. And they give you these formulae, and they don't give you a lot of harder ones. And for some reason I can memorise these ones that I'm given. Okay, so r cubed, 1 over 4 n squared, n plus 1 squared. Now, these are very important. Highlighter. Big blue parallelogram. Really badly drawn parallelogram, which is supposed to be a rectangle. Oh well. Pink too, because it is very important, deserves multiple highlighters. But how is that? I'm going to help you with that. How? So this is for r and r squared and r cubed, and that is not that. So let's multiply this out. It's n, r equals 1, 2r cubed plus 4r squared plus 2r. But again, these have coefficients. These are not written for coefficients, and they're written separately, not together. There's more factorising that can be done, clearly. Breaking it down, you can write it as separate components, so your r cubed component, your r squared component, and your r component. There are probably formulae for quartics and so on, but we don't need to know about them right now. So my book does not detail them, and neither did my teacher. So I don't know anything about them. These are the beautiful ones you're given for now. But still, these have coefficients and these do not. How do we deal with these? You move the coefficients to the other side of the sigma. I do not know why this works, but it does. It's all I need to know. It's r cubed, that is in fact 2 up there, plus 4. Make sure you do not forget to write the coefficients in front, and do not forget to write the r component either, because forgetting either one would not be good. Okay, so now you have this, and it's a lot easier to see your standard formulae and how they play into this. So you can simply sub these in here. So that's 1 over 4 n squared, n plus 1 squared. For now it's easier to simply put them in brackets with your coefficients outside. You can simplify in a moment. That is not squared. So it's 1 over 6 n plus 1, 2n plus 1, plus 2, n plus 1. Okay, and now you can probably see the simplifications you can do with the numbers and the fractions. So 2 over 4 is 1 over 2. As we go along, we're also going to multiply out the brackets to simplify it. It's 1 over 2 n squared, 2 n squared plus 2n plus n plus 4 over 6 simplifies to 2 over 3 n 2n squared plus 3n plus 1. That is plus 1, not plus n. You probably noticed that before I did and got annoyed at me. Sorry, as I said before, I am extremely tired. Just going to keep this bit in a bracket. So 2 over 2 simplifies to 1 over 1, which is just 1, and as a coefficient doesn't change anything, so we can just ignore that now. Woo. Those cancel, basically. And it's n squared plus n. Now to sort this out, you need to have the same denominator on each of the coefficients. At the moment, we've got 2, 3 and 1. Let's imagine this is 1 over 1. So all you have to do is multiply up so you get the highest, not the highest common factor, the lowest common multiple of the 3. In this case, that's 6. So multiply up, so this is 3 over 6. Also going to multiply the extra bits out of the brackets while I do this, because I'm lazy. Doing it in combining steps, because I don't want to write everything out. Because I am very lazy. And 2 over 3. 3 times 2 is 6, so 2 times 2 is 4, so it's 4 over 6, which is annoying because that's what we had there. 2n cubed plus 3n squared plus n plus 6 over 6 n squared plus n. Now, you can take 1 over 6 out as a common factor of all of them, and simply multiply out of the brackets by the numerator. So that leaves you with 3n to the 4 plus 6n cubed plus 3n squared plus 8n cubed plus 12n squared plus 4n, so 4, plus 6n squared plus 6n. Woo. And now we just have to simplify that, moving over here because I am running out of room. Keep 1 over 6 out. It's only one with indices of 4, so that's 3n to the 4. And there's plus 6 and plus 8 cubed. With the n cubed, so that is plus 14n cubed. And then for squared, you have plus 3, plus 12, and plus 6. So that is plus 21n squared. And for the simple n, you have plus 4 and plus 6, which is plus 10n. And all of these have an n in, so you can also take n out as a common factor, which is n over 6, 3n cubed plus 14n squared plus 21n plus 10. You would also factorise this, but I am feeling very lazy, so I am not going to do that. As I said, I am feeling very lazy and very tired. So yeah, just simplify that and we're done. It's the last bit. Woo! Well, I hope that was useful. If you have any questions, just leave a message in the comments and I'll get to it in a later video. Unless I can't answer it, then I'll try and direct you towards either a website that can, or just I'll tell you and you'll have to go and talk to someone who is slightly, just maybe slightly more qualified to answer your question than a 17-year-old AS student. Anyway, bye!